Alright, so this is problem 6 from problem set 3, and it says the midpoints of two sides of a square are vertices of the shaded triangle shown. Drawing the diagonal of the square pictured splits this triangle into two parts, one of which is a trapezoid. If the area of the square is 192, what is the area of the trapezoid? So I'm going to do this a way that's different than the two methods in the answer key. There's some overlap obviously, but this way is different than either of those, and so that will give you a total of 3 ways to think about this problem. So I decided just to try to find the dimensions, the relevant dimensions of this trapezoid. So I have 3 variables there, the base 1, base 2, and the height. That's what we need for the area of a trapezoid. And so once we have those, we know that the area is the average of the bases divided by the height. And so now we're just going to go about finding those dimensions one by one. Okay, so we're told that the area of the square, the entire square, is 192, which means that the area of one side here is the square root of 192, or if you divide 192 by 3, that's 3 times 64, so that can be written as 8 root 3. So because the sides of this triangle bisect the sides of the square, we know those are the same, which tells us that each of those is 4 root 3. So I'm going to label this as 4 root 3 here and here. Okay, and we also know the length of the entire diagonal, which is relevant, so I'm going to label that. So I'm going to kind of call it, just so I don't write in the drawing, the diagonal. Well, since it's a square and this diagonal is going to make that square into two 45, 45, 90 triangles, we know that the diagonal is just side times root 2. So that would be 8 root 3 times root 2, which is 8 root 6. So the diagonal is 8 root 6. And one of the dimensions we can get is base 1. Remember, I'm calling this side here base 1, this length here of the trapezoid. We can get that now using similar triangles because we've got here a large 45, 45, 90 triangle, and we have a smaller one here. And because they're both 45, 45, 90 triangles, and their sides are in a ratio of 2 to 1, right? Because the long side of the big 45, 45, 90 is 8 root 3. That'll give us a proportion to set up to find base 1. So that proportion would be, so I'm going to do this big base, right? The big base, which is the diagonal, that's 8 root 6. So 8 root 6 is to the B1, which is the base of that smaller 45, 45, 90. That ratio should be the same as you know, you can say 8 root 3 divided by 4 root 3, right? The legs, but that just reduces to a ratio of 2 to 1. And so solving for the base tells us that it is 4 root 6. So again, we remember we wanted base 1, base 2, and the height. So at this point, we still don't have base 2, and we still don't have the height. But the next thing we'll get is the height, which we can do in the next slide. All right, so remember we just found, if we're looking at the dimensions of the trapezoid, we found that base 1 is equal to 4 root 6. Okay, so now what we want is we still need base 2 and we need the height. So right now we're going to find the height, and we're going to do that by first finding, we're going to first find this height right here. Okay, so how do we find that? Well, that is the height of this smaller 45, 45, 90. And each of these sides, which is 4 root 3, is serving as the hypotenuse of yet another 45, 45, 90. So if we just divide it by root 2, let's give this a variable here. I'm just going to call it x for now. If we divide that by root 2, that kind of helps us go in reverse and find that side, because this side and this side should be congruent. So 4 root 3 divided by root 2 will give us that value. So just rationalizing gives you 4 root 6 over 2, which is 2 root 6. So this here is 2 root 6. Okay, and so then the way we can find the height now is, well, we know that this distance here, right, the height of the large 45, 45, 90, it's half a diagonal. Just kind of finish it up there. It's half a diagonal, and a diagonal is 8 root 6. Okay, so that's 4 root 6. So 4 root 6 minus 2 root 6 gives us the height. So the height would be 4 root 6 minus 2 root 6, which is 2 root 6. Another way you can think of it is that, remember, the dimensions are in a ratio of 2 to 1 for the large and small 45, 45, 90. And therefore the heights would be in a ratio of 2 to 1. So we now have base 1. We now have base, we have base 1 and we have the height of the trapezoid. The last thing we need to find is base 2, which we'll do in the next slide. All right, so the last dimension we need to find is base 2. So I'll put that up here, and then we'll have the area of that trapezoid. So the way I'm going to do that is I'm going to note that I also have another set of similar triangles. So I'm drawing this line here right through the middle of that isosceles triangle. And so then you can see that we've got two similar isosceles triangles, that little one and this bigger one. And that means that their sides are in proportion. And one of the sides, the base of the smaller isosceles triangle is base 2. So a little ratio will help us figure that out. But first, let's note that that the height of the smaller isosceles triangle right here is half of this diagonal. So this is 4 root 6. Okay, and then we also know that the height of this trapezoid that we're interested in is 2 root 2. So that means that the height of the big isosceles triangle, I'm going to write it up here, I'll call it H2. That is going to be 4 root 6 plus 2 root 6, which is 6 root 6. Okay, and now we've got a proportion to set up. So we can say that the height of the big isosceles triangle, which is 6 root 6, is to the height of the smaller isosceles triangle, which is 4 root 6. Okay, that ratio should be equal to the base of the big isosceles triangle, which is base 1, divided by base 2, which is what we're trying to find. And this allows us to solve for base 2. So cross multiplying, we get 6 root 6 times base 2 is equal to 4 root 6 squared. And that tells us that base 2 equals 4 root 6 squared divided by 6 root 6, which equals 16 times 6 over 6 root 6, or 16 over root 6. And if you rationalize by multiplying by root 6, you get 16 root 6 over 6, which is 8/3 root 6. So now we've got all the dimensions we need, and we are just going to plug in and solve. All right, so again, the last step in finding the area of this trapezoid that we were shooting for would be average of the bases, 4 root 6 plus 8/3 root 6 times the height. Those cross off. I'm going to distribute the root 6, so you get 4 times 6 plus 8/3 times 6, which is 24 plus 16, which is 40. And that should be the answer.